3, 2, 1, go, and we're live. This is Retraice segment number 89 for Wednesday, December 21st, December 21st. It's the solstice. I can't believe it. 2022, 10 p.m. Eastern, 7 p.m. Pacific. Retraice is about what's going on out there. The short answer to that is computer control. The long answer to that is natural, artificial, and strategic intelligence. Re89 through 81. Computer control is Re22. Hypotheses 1 to 11, Re17. Humanity is the best part, Re54. Retraces for outsiders, Re5 maybe. Outsiders are not players, Re52. Computer control is player-oriented, Re54 to 55. And we're learning to play, Re56. There you go. Now you can chase down all that boilerplate and find out what the hell I'm talking about. Multimap, again. You're damn right. You're damn right. We're not finished. I can't believe we're not finished. But remember, we're not really studying multimap. We're not really studying best first search. We are stretching our arms, working our legs to make sure that we can do the code that we need to do during the deep dive. This is December to Remember Math and Code event, not the December to Remember Best First Search event. And when we get to it in the future, we'll feel better that we went through these growing pains. Mathematical disclaimer, I am not a programmer. Programming disclaimer, I'm not a mathematical disclaimer, I'm not a programmer. Programming disclaimer, I'm not a mathematician. You see? It's a complicated world we live in. Quick shout out to Alexander Brown. He chatted to us during the live stream. I didn't see it till the end. I did respond to you, Alexander, but I don't think you saw it. So he helpfully pointed out that default dict is the same. I'm quoting him now. Default dict is the same as dict, but default dict inserts a default value instead of raising an exception when a key does not exist. That's awesome. Thank you very much. Much appreciated. And I confirmed that behavior. I checked Alexander Brown's facts to make sure this guy wasn't bonkers. He knows his stuff, clearly. He also asked, how long have I been doing Emacs, using Emacs? I'd say about 14 months. And I don't use it. I'm obviously not a programmer. I use it for the production of the show. So I do a lot of stuff in Emacs which is mostly text processing and the shell automation of the show, shell scripts and that sort of stuff. So that's why I know a little bit about Emacs, but that's also why I'm not really that great at it. Which brings us to another sort of meta topic that I just want to put at the front here and just own it. The code quality of Retraice code is not great. Okay, I know we're not following Python style guides. I know I'm not using PyLint. I know about all that stuff. I'm starting to work that into my process here. So let's go over and look at slightly cleaned up code. It's not really cleaned up, but and the other thing. Okay, for Christ's sake, it happened again. I was doing the switching, and you were looking at one thing, dear listener, dear audience. And like for the first few minutes of the show, or in the first 5 minutes of the show, there was like a 2 or 3 minute period where I was showing you a screen that was not the one I was looking at. That's all over with now. I've changed the way I'm live streaming so that can't happen again. But I'm also getting a little piece of hardware. You don't care about this. I'm going to get a piece of hardware that makes it easier for me to switch, because right now it's all look at this is my keyboard. Look at what I have to. I've got all these crazy things happening. By the way, these are Emacs, not that. Ooh, I almost dropped it. These are little Emacs tricks. Ask me about that, Alexander, or anybody who is fascinated by Emacs as I am. Okay, enough. Okay, hotkey's still working. Beautiful. I've tried to lay out our picture of our source code file here in Emacs a little better so that we don't have to keep jumping around, but I'm not as good at switching around and controlling Emacs windows as I am Tmux, so we might pay dearly for this. But up here, we've got all the top level stuff from our source file. This is all one file, so every window is just looking at the same file. I visited the file, and you're looking. Visited the file to put it in the buffer, and now I'm looking at the buffer from 3 different windows, okay? So the top level stuff is up here. Then we've got route problem. We need to keep in mind, this is the other thing about code quality. Like, I'm going to talk about this meta stuff soon, but I'm not going to do it right now. But there's some deep stuff to be said about how how we stylize our code and why we have to stylize, or why we have to use style guides, and why my code right now is horribly styled and whatever. But anyway, I'm not going to go into all that right now because we have to get done with this damn function if it kills us, no matter how late we go. Okay, so this is route problem. This is the subclass of problem that's going to help us solve our Romania map problem. What? Romania map problem. Now watch this. I'll switch over without having to worry about, not that. Let's put that away so that we can see it in our little alt tab. Okay, yeah, that's good. No. See, it's, if I'm slick at Emacs, then I'm not slick at, okay. So we're trying to get from A to B. We're deep diving starting January and going through June, inclusive artificial intelligence and modern approach. This is the book down here. It's pretty. This is the website for the book. Excellent resource. Obviously, we're using the crap out of it. This is the map of Romania. We're trying to get from state A to state B, Arad to Bucharesti. We want to use a computer to do it. We don't want our brains to do it. So that's our state space here. You're looking at our state space, and we're going to impose a search tree on our state space. Here's a search tree. And here's the source code. Here's where we're at in the source code. This is, so when you see our wonderful Candy Crush here, we're getting the source almost unmodified. I'm making little tweaks just for my own purposes, but almost unmodified from the AIMA Python official implementation in Python of the algorithms and data structures that we need to use the algorithms. Here is our GitHub, retrace.com. We'll get you here. And then we've done lots of notes corresponding to the segments. Okay, so when we talk about the what we're doing when we instantiate a route problem, which is a subclass of problem, we're working on that state space, and we're working on getting from A to B, imposing a search tree A to B by using Python code and not just yappa yappa typa and all that stuff. Okay, so our a problem has to have, just to go over one more time here, a problem has to have a state space, an initial state, a goal state, actions available at any given state, a transition model that tells you what happens when you apply an action to a state and how it takes you to state prime, action cost function, which gives, I don't know if you need that, but it never makes sense not to have one. But an action cost function is not the same as an evaluation function, which we talked about in the context of other things, and the objective function similarly. The evaluation function is actually going to be, that's going to help sort our list. So that is relevant here. Where is it? Oh, it's actually right. No, where's the F going? Oh, it's in the pseudocode. Do I have the pseudocode open? I don't. Yes, I do. No, I don't. Okay, let's open it. We got to look at that. Actually, I think I put it in one of these notes, didn't I? Yes, here we go. This is what I was thinking of. Okay, this is from Re89. So this evaluation function, this F, is going to sort our frontier. We haven't even gotten to that. It's freaking December 21st. People, I'm starting to panic. I'm really starting to panic. Okay, so then stop chatting about all kinds of nonsense and just get to the point. All right, get off my back, bro. Relax. All right, so just as we see here, not here, no, here. I put it in a few of these notes, this structure of a problem thing. So just as we see, we have an action function, we've got a result function and an action cost function. Those are the three big ones, right? Similarly, in our source, we have an actions method, result, which is our transition method, transition model, and our action cost. And then this is H for heuristic. We're not doing heuristic. We're not doing informed search yet. But I'm leaving that there. Just why not? Okay, multimap, our old friend, taking up way more time than he or she does. I can't decide. I think multimap's a dude, but he's one of those deceptively complicated people, I think. Okay, multimap takes an argument. Okay, first of all, why do we care about multimap? Multimap is in the map class. Map. Okay. Oh, watch this. Check this out. Bang, right there. Look there. Huh? I came across that just by accident today. That's awesome. That's a Mac OS thing. That's not a... Okay. So, and when you instantiate a map, as we will do... geez. Where do we do it for the first time? Well, they do it with Romania here, but I've commented out and I've removed a lot of clutter that had accumulated from previous segments that's no longer necessary for us to be able to look at this a little bit more cleanly. And I also... I don't know why, if anybody cares about this. I also changed my my autofill column width to 80 characters. I read about the argument for keeping it at 80, and you're looking at it. Look at this. So I can do side by side of the same file cleanly without a lot of truncation, like these dollar signs at the end here. That's truncation. You can you can turn that off, right? So toggling truncate lines in Emacs, but then it looks like garbage. Okay, so we toggle truncate lines so that, but really we don't want to have to truncate anything. We want everything to fit within our 80 column width. So I've started to restructure in that way. But it's it's a work in progress, blah blah blah. But that's code cleanup. That's code quality, which we don't have, but we will aspire to have, and then eventually do have. Okay, so multimap gets called here. What is neighbors? Why are we trying to get the attribute neighbors? Why are we trying to create an attribute neighbors of our map object? Because neighbors are actions, right? That's the right way to say it. We're going to produce a list of neighbors which correspond to the actions available at state A, or whatever state we're at. We need to produce the neighbors of A, and it needs to be like a single list. I think too is part of why we have to complicate this code a little bit. So multimap takes links. So our links is t-links. Okay, this dictionary here. So we've got these are key value pairs. So A to Z, and that's 75 miles. A to S is 140 miles. A to T is 118 miles. And then Yo Mama and Data, they all got involved. Nobody knows how. Okay, so it's important also to point out. I don't think I've always been saying it clearly, but the reason that we had those side effects, that weird behavior, where before I probably deleted it, didn't I? Before, well, this does it right here. This is related, I guess. The multimap does not. Multimap is not the culprit when we had those side effects being exhibited on our links dictionary. It was the fact that map, okay, the map class, I just love doing that, is calling multimap and passing it the links outside of itself. Okay, so we're having side effects, even though we're doing object-oriented here, we're having side effects because multimap is I don't know if they meant to make multimap a method within class, but it's not indented. I'll show you. It's not indented. Oh, geez, I can't, there. Yeah. See, it's not indented here, so if you now they, it's a good way of passing a key value list or dictionary and getting back the neighbors, so they might not have wanted it to be in the map class, but nonetheless it caused us some headaches and some confusion. So from here, links gets passed to the modified links, which is the one that has this, the reversibility in it. Okay, the directed version. Come on. Okay, this for loop doubles the size of our dictionary by adding the reverse entries to it. So like, okay, if links starts out, actually, let's just do this. So I'm going to try, sometimes it makes sense to use IPython, sometimes it doesn't. I'm going to try and get the best of both worlds here. Yes. So we're going to load our file, okay? So this is sort of a compromise between just running Python from our shell and running an interactive IPython, which is the best sort of interactive Python, but also, sometimes it has some downsides. Like if I go to previous command, I have to recall the whole damn file here. That's a mess. I don't like that, and I don't know how to get around it. I'm sure there's some way, but I don't know it yet. Okay, so if we print t-links, thank you. See, they do autocomplete. Okay, print t-links. They do autocomplete, but they don't always like show you what they're IPython doesn't always show you what it's going to autocomplete. But I know if it doesn't autocomplete, okay, so for here, if you don't see anything, tab it out, okay? But if you see see load, oh. Yeah, so like if you tab this out, well, oh, look, the way, Command F does that too. Control F or Control E, and not Command, Control E does that. That's my favorite is Control E because that's Emacs-y. But like there, Command E does that, but tabbing it out does something different. Anyway, little fun facts. Okay, what are we doing? So print tlinks. Now see, I can't tab that out. Look, I can't, look, I'm tabbing that out, but if I do Command E, then I can do it, which is fine. But then I end up trying to do that elsewhere. And then, okay, so there's our dictionary. Now, watch this. We're going to, what's the best way to, where's our map? Where's it? Whoops. Let's see. Tmap? I didn't leave tmap in there. Stupid. All right, whatever. Tmap equals map, and it takes the argument of tlinks. Nope, sorry. Tlinks, and tlocations. Oh, geez, see, this is going to get annoying, but I like keeping it down here in space. Bang. Okay, so now let's do print tlinks again. Oh, what happened? What happened? Well, the reversibility happened, okay? This thing, okay, this for loop, this non-directed, meant for non-directed for loop, oh, geez, that's ugly, got executed on our links dictionary while it was being instantiated as a map, or being a part of the instantiation as a map, but then it got passed out, and it's the same object. It got passed out to multimap to get the neighbors, but multimap is a standalone function. Multimap is not object-oriented. Multimap is going to have side effects, and so it changes our dictionary. I don't know exactly why it would do that. I feel like it should be something different in, I feel like the object-oriented should, create basically a copy of links and work on that and then pass the copy out, but that's not what happens. It's not the behavior. So now our tlinks is permanently changed, and that caused us a lot of confusion. But doesn't matter. It was fun learning it. And right, so multimap. So what's getting passed to multimap is this dictionary. Okay, this big long thing, okay? The doubled version with the reversible paths is what's getting passed to multimap. So any behavior that we see from multimap, or let's say if we, okay, so let's try and use the methods, or at least look at the attributes. What is the, okay, so what's our test map? Dot. I don't have to do print, but it's good form to do print. See, I can't delete that. That's ridiculous. I can use the delete key, but I can't okay. Let's do print. I think this is the better practice. Neighbors. Okay, let's just print the tmap neighbors. Okay, so let's see if this is correct. Yes, A's neighbors. Yeah, that looks totally true. Okay, so we just called the attribute, and where did it get this attribute? Okay, first of all, we're looking at the attribute neighbors, okay, of our instantiated map. Our map is called tmap. The attribute neighbors is set equal to the multimap function as applied to the argument links, and it's not our original links; it's the reverse non-directed version. Okay, and multimap definitely looks like it's doing the right thing. What it's done is if we really want to know what the neighbors of each state or node in our graph, what the neighbors are. A's neighbors are ZST. Yo neighbor is only mama. Mama is dada and yo, because you can get from mama to dada, but you can't get from yo to dada. Z only has one neighbor. S only has one neighbor, and T only has one neighbor, and dada has one neighbor as well. So there's some islands, or at least there are two islands in our state space, and that all corresponds to tlinks, okay? There's nothing, even though we're seeing a modified version of T-links when it gets, after we instantiate a map, because it gets passed out to multimap and side affected, it doesn't change the partition, I guess you would call it, the partition of the space, because all it's doing is reversibility. You can't, it's not adding any entries that weren't already linked or weren't already adjacent or it didn't already consist of two adjacent states. Yeah, that was clear. That was way clear. I'm glad he said it that way, because before I was starting to understand and now I'm confused. Quiet you. All right. So what have we done? We looked at the neighbors attribute, but we're not examining the map class right now. We have to finish with multimap. So let's look at what it did. So Alexander Brown told us about default dict. So it's like if we were to just, okay, let's just do this. Print dict. Oh, man. I become lazy. Okay, let's just do print dict, okay? Just as a baseline. Nothing, okay. That's, oh no, I did it again. List is not iterable. Is not iterable, really? I thought I got good output from this earlier. List dot type. Oh, not that. Damn it! It's gonna drive me crazy. No. What do I want to do? Not there. I want to list dot dict. If they gave us a good one. No, I don't know what I'm doing here. You're seeing my programming noviceness. What I'm trying to ask is, type. Jesus. Sorry, I should. As if I say it out loud, I understand better. No, that's not it. What is how do I find out what type of object it is? I can just stop it. Oh man, I hate that. Print dict, or no, print list. Yes, so what did I do before? What was I? What the hell did I just do? Type list. Print list. Yeah, okay, so what does the type function do? Python built-in functions. AG. Where's the type? SS. You wonder what I'm doing now. That's Vimium, if you're wondering what that is. With one argument, return the type of an object. Well, why didn't it return the type of the object? Return value is a typical object and generally the same object as requested by object class. Yeah, class is what I was thinking of. But still, my way would have worked. What did I do? I did type. Oh, crap. Type list. That seems wrong. What's okay, default dict. No, see, that's not doing what we want. Why is type not doing what we want? List class type. I don't know why that's not telling me what type of an object it is. But if we just say list, it's just echoing it. See, this is what I don't understand. Like, if this is the list function. I wasn't telling it it's a function. Nope, that wasn't it. Class. No, I'm not correctly doing anything here. Well, let's see if it works on default. This is not what I'm expecting. Stop it. There. Okay, so I really do have to print. in IPython. I thought everything, okay. I thought it could just read my mind. It can't? It's stupid. All right, back to where we were. Let's just do this in a way that we understand. F you. Okay, so it's class is type. Type is a class? I don't get it. I don't get it. I'm not a programmer. I don't know what I'm doing. I'm a podcaster. Anyway, default dict, if we just print it as we saw when we wanted to do something else, default, no, default, man, that's getting annoying. Come on, man, stop. There can't be that many suggestions. So when we print the default dict with the argument list, it's an empty list. It's an empty dictionary, okay? If we just print default dict without the list, look at that. Okay, we got to do this. We got to look at this. So default dict with the argument list comes back as an object. It's a list object. Whereas default dict with no argument is a dictionary. Okay. I think I'm starting to get this. We're getting there. So I think what that means is that default dict without the list argument, without giving default dict, it's one of these things they call a factory method. Don't ask me about that. I think that's what this is. Maybe it's related to this. Factory. Okay, so if you don't give default dict the argument list, it comes back without an object type, but it still has braces. Doesn't that mean it's a dictionary? Anyway, it certainly. It doesn't have. It's a container. Like a dictionary is a kind of Python container. Okay, and so. Whoops. Gosh, I'm going to do that all night. If we don't mind not understanding what a none class, it's not like a default dict is. Oh well, we get this from somewhere, right? Actually, we get this from over here. We import from collections. Okay, this is interesting. Collections is interesting. Python collections. So the best explanation for this is the documentation. That's not always true. This module implements specialized container data types, providing alternatives to Python's general purpose built-in containers, dict, list, set, and tuple. And our default dict, this is where Alexander Brown was instructing us. The sort of opaque way of saying what he said is dict to subclass that calls a factory function. Yeah, factory function to supply missing values. And we're not going to go into factory functions because it's kind of a heavy topic. Heavy for me. So this is what collections. Well, this is what's in collections. This is what we imported default dict, and we actually import DQ and one other thing from this list. I don't remember which one. And counter. Yeah, counter. A dict subclass for counting hashable objects. Okay, so that's where default dict comes from. It's sort of a more special. Whoops. Where am I? There. Okay. It's a specialized. There's a specialized container, and if you give that specialized container the argument list, it comes back as a subclass. The object that gets instantiated is a subclass of list, the list class of objects. But default dict without an argument is not a subclass of list. Oh, and I bet, what other arguments can we give it? Set. Let's give it set. Okay, so let's do, darn it, set. Yeah, see, class is now set. So whatever argument we give to default dict, it becomes a subclass, or it's an instantiation. Our default dict becomes an instantiation of a class. But if you just call default dict without an argument, it's not an object. It's not an instantiation of a class. Okay, great. What were we talking about? All right, so we set our result object equal to the default dict list. And now from here on out, as we learned the hard way, we're going to be dealing with result. Okay. For key value in pairs, damn it, okay, so pairs is our links. So in our case, t-links, the modified version of t-links. Gosh, I want to add annotation here, but I don't want to mess up my norms. And I still, no, geez, there's something wrong here. I used to be able to just, no. No. There's something wrong with that. I don't want to have to, okay. I don't want to have to do that. That's so stupid. My autofill? No. No. Oh, I gotta do this the hard way. I'm embarrassed to do it this way, people. I really am. Let's see, command universal 10 space, and gotta do it again. This is so pathetic. Okay. So pairs, let's say, no, we don't need to quote it. Pairs is now our reversed, oh, we gotta do, let's see, my new key bindings for fly spell. There we go. Here, good. Okay, that underlining is my fly spell checker. I'm terrible at spelling and programming. Okay, pairs is now our reversed t-links. And so this is where, I'm going to add that to our dictionary. And this is where things get interesting. So if I pass to multimap, like if we just want to watch the behavior of multimap on our on something other than t-links, because t-links is a very specific state distance dictionary. It's got 3 pieces of data for every entry in itself, in every dictionary entry. Let's see I already know what happens here, but let's watch it. So if we do multimap, let's just do print of multimap. What are we giving it? T-pairs. Okay. Not enough values to unpack. And what it's talking about is the difference between this is a pair. Like, I mean, it makes sense. It's like, I know that you can think of a key value pair in this dictionary. So, the key value is here. Oh no, what did I do? Oh no, I broke my wonderful, no, that's okay. I can fix that. There we go. Oh, this is all gobbledygook now. I had this all so nice. Okay, let's just bear with me. No, XO, and let's do that. No, we're good here. Okay, we're doing okay. What did we have here? We had, I think, route problem. Yeah, okay. This is a key, and this is a value. 75 is a value in a dictionary. A dictionary is about key values. But like if you had a list of just things in parentheses, these would be tuples. Okay, these are mutable. Tuples are immutable. Dictionaries are mutable. It doesn't matter. You can Google it. But the problem with our t-pairs here, which we just ran and got an error, is that it doesn't have a pair in it. Like I thought maybe the pair was the key and the value, but if we instead, why isn't that syntax highlighted? That bothers me, that this isn't, that this, I love doing that, no, that doesn't work very well, isn't syntax highlighted. But let's do, what do we call it, new t-pairs? New t-pairs. Now we get an okay list from default dict, which is what gets returned at the end of multimap. Okay, so return result. Remember, result is set equal to default dict. Oh, geez, none of it sounds good. It sounds like we're going to get into some ratings issues here. Okay, so what does it do? It takes the, okay, first let's print. Okay, that's new t-pairs, new test pairs, okay? And then what does multimap do to it? that. Okay, so new T pairs is the pair JA. And so it basically takes the pairs of our T lengths, of our actions, ignores the cost, the 75 of A to Z, let's say, or in the case of JA, ignores the 12, and it turns those tuples that are our keys in our dictionary into key value pairs. Now, how are we supposed to know it does that? It says that. In code, it says it, not in English. I speak English. I don't speak code. For key, comma, value in pairs. But I see that's, it's not, it's a misleading choice of, I think you call this a variable, because, whoops. Oh, for Pete's sake. Can we just, okay. Because we're dealing with dictionaries, like key value in dictionaries to me means the key is in the parentheses, okay? And the value is after the colon. But what they're doing here, and these people know what they're doing, not me, but I can still complain, can't I? They're using key value instead of, I don't know, Never mind. It's a little bit confusing. And this syntax here is basically taking, since result is a dictionary, right? Because we set result equal to default dictionary with the list argument, which made it into it's subclassed list. Why does it have to subclass list? I don't know. I can't get into that. I can't go too far afield here. Got to stay on the boat. You're appending the first piece of data. I don't want to say key value because it's not a key value. The key in that dictionary is both of the things that we're working on here. Val, as they're putting it here, is part of the key if you're talking in a dictionary. I think. I don't know. Like, don't listen to me. But then we're appending the val. Okay, so in brackets here will be the key, and the in parentheses will be the value. Now in the new dictionary, that terminology is correct. In the new dictionary, okay, this is a key value pair, a key value. Okay, so that's probably why they did it. Good thing they can't hear me right now. Okay, great. So what is that going to look like when the time comes to feed this argument the actions dictionary into a map, and then thereby into multimap? Well, it's going to take every one of these. Let's use my every one of these pairs, these tuples, OZ and then OS, and it's going to turn them into a key value dictionary. Why would it do that? Good question. What were we doing again? So we're trying to get the multimap is about getting the neighbors of our action in our state space, which we're getting from links, which is the actions. Which is the actions. And how else would you get the neighbors, right? The only other thing you're going to be getting in your when you instantiate a map, because we're doing a route problem, remember? So we're doing a route problem, which is a subclass of problem. Problem doesn't require this sort of stuff, a map and states and action. Well, it requires states and actions, but it doesn't use coordinates and stuff like that. But the only two things we're passing to to our instantiation of map is a dictionary of actions, which is this top thing, the links we're calling it. We should just call it actions, but we're not. We're using their code as much as we can. And then we're passing the bottom thing, which is the states, which are just coordinates. There's no way to find the neighbors of A from this second dictionary. Okay, there's literally no, it doesn't matter what the coordinates of A, Z, S, T are, because we don't know if they're neighbors unless we have these definitions of links, okay? So stop doing that. A, and A. Okay, those three A's have the neighbors are defined right here. We're never going to get that if we go down here. All we're going to get is its coordinates. Okay, so let's undo. Okay, and all right. So what are we doing now? Is it over? Can we be done with multimap? Well, we've seen it behave. We've seen it take a dictionary. As long as it has as long as it has two states, it will just ignore the cost or the distance over here and turn these into a dictionary. Okay? Why do we need that? I'm losing track of what are we doing? We need the neighbors. That's all we need is the neighbors, right? So the only thing that multimap is supposed to do is populate this attribute neighbors, and that's what it's doing. Neighbors has nothing to do with the costs or the distances between them. We just want to know what the neighbors are. Okay, so if we do tmap.neighbors, we did that, right? Oh, that's so pretty. We didn't do that before, and that's so much better. That's so much better. I love the new lines in that. What did we do before? Afraid to go up because I'm going to get the whole file here. What did we do before? Oh, we did print tmap neighbors. That's ugly. So thank you, IPython. Thank you for being a friend. That is so much better than that, right? Well, why can't we just get that? How do we get this if we're not in IPython? Okay, let's do something fancy here. That, okay, and Re89, and CD89, and Python. There's only one file, but I have to. What happens? Let's just see what happens, because it's just fun and games. What happens if I say that? Oops. It's okay. Yeah, this should work, right? I mean, I don't think it's going to work, but we'll see what happens. Yeah. Tmap is not defined. Oh, screw you. Of course it is. It's not? Oh, it's in IPython's memory, but we probably commented it out, didn't we? Okay. Geez, no. We didn't even, it's not even in the source. Okay, I gotta put that in here. Tmap, I'll just do it from memory, equals map with the arguments t-links and t-locations. Happy now, computer? Happy? Yeah, we get nothing back. So we can't, this doesn't do anything in the normal Python world unless we print it. But in the IPython world, it's beautiful. But we know that we know something. We know secret knowledge. Okay. I guess I will comment that. No, I won't. Now I will. All right. That's all multimap does. It strips from the links. It strips the two states and turns them into a dictionary so that we have a dictionary of neighbors. And when it gets past the dictionary in the first place, it has the reverse second half as well. So it gets a complete list because we're not dealing with a directed algorithm, I guess we'd say. Okay. I think that's it. That's multimap. I don't feel like there's anything mysterious. I mean, I could, you need to practice with this, but it's obvious what it's doing. So let's do it. Let's be done. We are not making good time. We are not making good time. So I'm going to shut up and turn this off. I mean, not today, but I mean, like on this particular best first search, I feel like we need to come up to periscope depth and figure out how to get to B. We started at A. We are in the Indian Ocean right now with multimap, and we need to get back to Bucharesti quickly. It's December 20th. It's the solstice, for crying out loud. I'm feeling the pressure, but I love it. All right. All references and notes and code, or the most important code, will be in the PDF notes. That's in the RSS feed, in the YouTube thing, in the YouTube description. Retraice.com, Retraice.com. This has been segment number 89. And same time tomorrow, 10 p.m. Eastern. We're going to do a doubleheader soon. We have to do a doubleheader soon because we got to get to 100 by the end of the year. And I think I got to do one more doubleheader. So, and there's plenty to do. So much to do. But not when things like multimap snare you, snag you in a tar pit. All right, enough. Signing off. Same time tomorrow. Signing off.